Hello, everyone. Good morning. Dear authors and invited guests, welcome to the session 6F. My name is Siddhi Auti and I'll be moderating today's session. So, if there are any queries, you can contact me. Uh, it is my great pleasure to welcome you all to the Ninth International Congress on Information and Communication Technology, ICICT. The ninth edition of the conference is being organized in a hybrid mode. The physical event was organized in London, UK on 90th and 20th Feb 2024. And the virtual event will be organized today and yesterday it was organized on via Zoom meeting on 21st and 22nd of Feb. I hope you will enjoy this session and find it knowledgeable and interactive. In this session, we will be having six presentations, and each presenter will be given a time span of 12 minutes and extra 3 minutes for the Q&A. I request all the participants to kindly consider the time constraint and conclude your presentations within 2 minutes. I'll be reminding you in 10 minutes. I will raise a gentle reminder. And there is another request to all the participants to that you all stay connected with me till the closing remarks. And if you have any queries or update or any technical issue, you can tell me in the chat box. Now I will get started. Now, just before we get started, I would want to introduce everyone to the session chair for today's session. So our first session chair for today is Professor Bal Vide, and he's present with us right now. Hello, sir.
Hi
So,
everyone.
Professor Vide is the director of the Center of Communications Technology Research Group. He obtained his PhD from University of North London, UK. He had worked as an academic at Open University and Leeds University. Prior to this, he was a research and development electronic engineer in the Future Products Department at Teledyne Defense and PYE TVT Philips in Cambridge. His research in the areas of microwave and wireless communications, encompassing 5G mobile phones to satellite technology. I welcome Professor Balvide sir to today's session. Now we'll proceed with the papers. Now I would like to start with the papers. Let me just connect to the PPT. We have another session chair for today, but she will be joining us shortly. Now let's get started with the papers. So the first participant, Mr. Adrian Lopez, will be presenting their paper. I request Adrian sir, if you're in the meet, to start your presentation. Mr. A second. Adrian sir, if you're with us, please let us know, or any co-authors. Okay, actually, another chair is also present here, so I would like to introduce them. So another other chair of today's session are Dr. Priyanka Sharma. Uh, Dr. Priyanka Sharma is currently working as a professor, IT professor and dean at Rashtriya Raksha University. She also has worked as a dean research and publications and director in Raksha Shakti University, and she was the head of IT and TC department and a director of CITEX. She is having total 23 plus years of experience in teaching. Her research work on cyber law framework has been submitted to Justice BN Shri Krishna Committee on Data Protection Framework. I welcome Dr. Priyanka Sharma. Ma'am, would you like to say something? Are you with us? Okay, we'll continue with the presentations. So I request Adrian sir, if you're present in the meet, please start with your paper or we'll proceed to the next presenter. I think Adrian sir are not present in the meet right now. He will join us shortly. Meanwhile, we'll proceed to the next presentation because we have a time constraint. So the next presenter of the session is Mr. Brian. Are you present in the meet? If he is not present as well, we'll have to proceed. Uh, Just okay. So there is something. We are replacing one participant with another presenter of 8F session. So for now, Ricardo Gomez sir will be no.
D.
Okay, sorry. This there was some misunderstanding from my side. Uh, Brian sir is also not present with us, so I'll proceed to the next presenter. Mariam ma'am, are you with us?
Yes, I'm here.
Ma'am, would you like to present right now? The previous presenters are not present, so meanwhile you can give your presentation.
Yes, no worries.
Okay, I'll stop sharing my screen. Then you can start with your presentation. Thank you, ma'am.
You're welcome. Can you see my screen?
Yes, ma'am. We can see your screen.
Okay. Is it clear for you?
Yes.
Good. So thank you very much for such amazing opportunity. So first of all, the title of my presentation will be about diffusion-based convolutional recurrent neural network for improving sound event detection. My name is Dr. Mariam Aldabil from University of Hafr al-Batin, College of Computer Science and Engineering in Saudi Arabia. So my presentation will, conclude the paper I submit for this amazing avenue, and it will highlight this content. First, I will talk about the background by defining what is sound event detection. Then I will give a highlight about the aims and objectives, going through the main component of the system that I proposed in this paper, which is DCRNN model. Then I will go through some of the experiments I conduct, some of the experimental setting if we have enough time, then we will conclude the presentation. So first of all, I would like, just to highlight the definition of sound event detection. It's normally aimed at providing device with the capacity to identify, recognize, and classify acoustic environment. It can be categorized also as the process of identifying the presence of both overlapping and non-overlapping sound event, as well as determining the beginning and ending duration intervals. So this is what does a sound event detection mean. There's lots of studies, lots of challenges for this specific areas. But in this work, I try to highlight, most advanced work I did for this particular area. So the aim and objective of this work, as I mentioned, is using some model, which is a new model that is normally used for the computer vision, which is the latent diffusion model, and try to combine that with the convolutional recurrent neural network in order to combine the benefit of those two together to recognize the sound event. The system was trained using a very large data set and then used that concept transfer learning in order to adapt to the intended job to overcome some of the shortage we have, which is the lack of data. The latent diffusion model here will try to compress the audio, feature, which we call it here as a Mel spectrogram. Okay, it will compress it into a discrete representation. Then will we have a CNN, which is the convolutional neural network, which is coupled with the RNN as a front end to build the feature map. Now, this feature map is then we will use it in order to forecast some temporal spectral attention map using a model called attention model. Now, for more adaptive feature refinement, the input spectrogram, we will multiply it by this, generated attention map, and then, well, we will have this trainable scalar way to combine back-end RNN with the fine-tuned features. So this is the overall objective. I will go through the framework at, a very abstract level, not into details, but I will focus in one more area. So if you notice here, we have this framework of what we call a diffusion-based convolutional recurrent neural network, which we will refer for it as DCRNN. It has 5 main components here. If you can notice, we have DC3 blue, which is the diffusion-based model. We have the CNN model. We have the feature map attention model. We have the RNN model, and finally, we have the fully connected model in order to have the output. Now, I will not go into details about the CNN and RNN, okay, or also the feature map model. I will just give a brief, introduction of how we integrate this diffusion model. And then if we have enough time through the experiment part, we will discuss how we use the CNN and the feature map as well as the RNN, as we will, use different version of these models. So as I mentioned, we have 5 main models here. The first is Latin diffusion model. Then we have the CNN. Then we have the feature map attention. Then we have the RNN. And finally, we have the fully connected layer model. We will focus on the first part of the framework, which is the Latin diffusion based. It has 3 main components or 3 primary parts. The first, we call it as encoder. Then we have the Latin diffusion model, and then we have audio variation autoencoder. Now, we will try to highlight the main theme of every single main part of this, model. The encoder is normally a pre-trained model in order to obtain the encoding from that, model. Now, the token count and the token embedded size will be, representing from this pre-trained model. Then we will hold the ET here as a constant throughout, the reverse diffusion process. And this may require some prior knowledge of the audio in order to map it with its generation. Then we have this audio prior, which as we call it S0, under the direction of the encoding that we defined previously from the pre-trained model. Now, this process will be referred to it as forward and also reverse diffusion. And for this process, we have a number or a series of Markovic, chain model, which is component of Gaussian with predetermined noise parameter. Why? In order to get more distorted alteration of the sample. Now, this equation will represent that into more details, and you can notice that we have this Markovic, or the Gaussian distribution here. Then we have a more direct sampling of the SN, which is the sample. Now, the order of that or the aim of that is having more, noisier version that can be applied using reparameterization here. The last stage of this forward procedure in the diffusion, we will hold we will generate the SN, and it use a noise estimation for the purpose of denoising and recovering the S0 using a loss function. So this is just highlighting how we go through, the Latin diffusion model, which is the first part of the whole framework, and then we will have the remaining 4. Let's go now for the resultant analysis. Now, for the resultant analysis, I will go through the experimental setup, and then I will highlight how many experiments we will do. Okay, I did more than that. So if anyone would like to know more, he or she can contact me via emails, and hopefully, inshallah, we will have a paper, submitted in the near future to just, have the more result we get from this framework and more experiment in different setting too. So in this result, or in this analysis, we have two data sets. Actually, there is a main challenges. They announce it and they have a website. They have a different version, but we choose to have, this two data set to experience the model for. Now, this data set, which is DCAS 2016 and DCAS 2017, they have different tasks and their challenges in their website. So for this specific task, which is sound event detection, task 3 was dedicated to that. So we choose a data set from that website. Both data sets include everyday noises that are separated into inside and outside or outdoor setting. Now for the DCAS 2016, the audio is mono, not binaural, and has 44.1 kilohertz as a sampling rate and sampling frequency. Now, it is the same case also for the DCAS 2017, but what is surprising here, the DCAS 2017, it has more street noise and more human voices from more like original authentic recording in that data set. And more typical, setting, we have inside residence and we have outdoor residence neighborhood. So it's more challenging actually for the framework to get, a good result for. For the measures, how we measure, the accuracy and, the effectiveness of the framework we have, of the method we have, we use two measures here. The first one is the error rate, and also we have the segment-based, which is F1. Now, the F1 here, which is the segment-based, is the harmonic average of recall, R, and the perception, B. And we have this value between 0 and 1. Now, this is, a highly, common measure that is used in like machine learning based, challenges and, detection and classification. Now, how we compute it, we have F1, it's 2P time R divided by B plus R, and for every P and R, we have a different equation to calculate it based on the true positive, false positive, as well as the false negative. In terms of the error rate, we have it as, the number of sample which is classified incorrectly. And it is computed as, the sigma of ST plus sigma of IT plus sigma of DT over the range from T equal 1 to T, which is T representing the audio event that is in segment T, because, both measure will be at a segment level. Now, the S will represent the number of times that the model incorrectly label a sound event as a sound event, and IT will represent the insertion, and D will be representing the deletion. Whereas the N will be the sum of the acoustic event from any intonation we have. So these are regarding, the measures and data set. Now, let's talk about the general experimental setting we are having. Now, we are having a features because this is, a machine learning based application. So we should have a feature here. Our features is a log millispectrogram, which is 40 times 256, which is T as a time of frames, and F, which is the frequency samples. The overlapping frames, which is 50%, and the frame size will be 40 ms. We say that we're having diffusion models, okay, and for that we use the stable diffusion neural net architectures, which will serve as a foundation for the diffusion model we just explained, a few slides back. In this UNNet model, we employ 8 channels and cross-attention dimension of about 1024. Then we use the Adam optimizer, which is a well-known optimizer. We use it normally for CNNs, and we have this learning rate, which is, a commonly used tool. And then we have a maximum of about 3,000 iteration in order to choose the experiment for the purpose of improving the CNN. We use the PyTorch also to build the CNN architecture, and we use three topologies here. We have AlexNet, VG4, and Net4. We used them in our experiment, and we compared the output of every single one with different polling topology to see the result. We have also a three-dimensional feature map that is, we converted into one-dimensional tensor using a global polling layer that comes after, the CNN layer or the convolution layer. Why is that? Because we actually aiming to have fewer feature dimension that will help us, in the computation process. Now let's look at the number of experiments we are having. We conduct for this specific paper three main experiments. The first one, we have to compare different polling strategies or method for CNN classification or topologies we are using in the same model. So as we mentioned, we have for this model 5 submodels. The first one is the fusion model, so we fixed that, and then we have CNN. We have three different versions to see the output of that. We have the attention model, and we use different polling strategies here, and then we have the RNN and so on. Now for this experiment, we use three different polling strategies. The first one is called the global max GM polling, whereas the feature map here, it has the greatest value from every Timbaland frequency band, choosing at every single frequency band or a frequency channel. Then we have GA, which is the global average polling. We compute it by using the average value of each subfeature map, where with every temporal frequency band contribute equally to classification. Then we have the last one, which is the temporal frequency global attention, that we refer to it as TFGA polling. The aim of this polling is to decrease the dimensionality of a feature map through measuring the contribution of every unit of the temporal frequency, features. Now we have three main polling, and also we have three main topology. You can notice here in this large table, we fix, as I mentioned, the diffusion model. We don't have any change at that point, but we change the classifier at every single, stage. And when we change the classifier, we change also the polling method for two data sets, the DCAS 2016 and DCAS 2017. We measure F1 and we measure ER2, and we try to find which setting will be the best for our scenario. And what we found actually is using AlexNet, okay, and with TFGA, which is the time frequency global, polling, it's outperform in both DCAS 16 and also in DCAS, 17, compared to the GG4 and Net4. And then for the second, experiment, we have, a comparison of the RNA.
Ma'am, extremely sorry to interrupt you. I
Mhm.
would want to request you if you could just wrap up your presentation because we are running out of time and it has already been overtime. If you could
Okay,
just
I
conclude
will
your
go
presentation.
I will go for the last experiment. I think, 1 to 2
Thank you
minutes.
so much, ma'am, for
It's
cooperating.
okay. Now, to just assess the, efficiency of this method, what we do here, I try to compare the method with the, state of the art as well as the baseline. Now, state of the art will be the winning system from, that challenge that, introduced at 2016 and 17, and the baseline that they release it in their website. Now, I will not go into details. It's clear for you, and also it's clear in the paper. We can discuss it later on. But also when we run this, scenario using the best scenario for the previous two experiments, we find that the method we proposed outperformed the baseline as well as the winning system. So this is the main idea of why using, the fusion model has a very good and, very important, impact on just, having or posting the result for this specific, scenarios. And then I will conclude, the presentation here. What we did in this study, we combined the benefit of several networks as well as the latent diffusion model, and for the task of sound event detection. And what we found, the experiment finding indicate that the suggested techniques we have, which is DC and N, outperform both the state-of-the-art and the baseline method for both data set we have, DCAS 2016 and DCAS 2017. Thank you very much for your listening. And, if you have any question, feel free to ask it. Thank you.
Thank you, ma'am, for your presentation and wrapping it up a bit because we have a time constraint. Now I will move on to the next presenter. Ma'am, could you please?
Yeah, can we ask one question?
Yes, yes, sir, sure.
Yes.
Hi, Dr. Dable, that was an excellent presentation. What kind of sound effects were you trying to detect?
The sound event, which is outdoor and indoor. I couldn't have, include more about that type of data, but, some of them will be related to sound of, animals or alarms, for example. So it's depend on the type of the data set you are having. The DCAS challenge, they have an amazing website, and they actually conduct some recent also, challenges, which is more advanced data set. So it's really good for, alarm sound, for animal sound, for human being sound, when you try to just classify and recognize these sound events.
Well, that's excellent because you can actually use to detect, for example, children in a very noisy environment or something like that. Absolutely, that's fantastic. Thank you so much for your answer. Thank you.
Thank you. Thank you. You're welcome. Shall I stop the share now?
Yes.
Okay.
So the next presenter for today's session is Mr. Adrian. Sir, are you present in the meet right now? I guess he's not
Yeah,
in the meet. Uh,
yeah,
are you here? Okay, sir, I will want you to start your presentation.
okay.
I request you to wrap it up within 12 minutes.
Excuse me? Well,
Yes. I'll stop sharing my screen now, then you may start with your presentation.
yeah, one moment, please. Yeah, I start. Hi, everybody. My name is Adrian Lopez, and I'm from Ecuador. I am a student in University Polytechnic Salesian, and the name of the paper is a new method for prediction, the importance of the scientific articles on topics of interest using natural language processing and recurrent neural networks. And this is the content of type in this presentation: introduction, main contribution, data science architecture and deep learning method, experimental design, results, and conclusions. Yeah, for the introduction. Currently, search for relevant scientific information for our research is a laborious and difficult task that can take a lot of time for the researchers. And for this, using natural language processing with recurrent neural networks and non-negative matrix factorization, reduce the time for the research, find the articles or the content relevant for your investigation. In the main contribution, in the case of the study, is only the title of the paper. Is a method using natural language processing. And for this method or for this study, separate the architecture in three phases. Phase one, processing or pre-processing, that in this part state the natural language processing and they recollect the articles most relevant for the investigation. In the phase two, machine learning is the method of the models that evaluate for comparison your metrics and create the model, the best model for this problem. And the phase three is the prediction using this model with the natural language preprocessing can release a new prediction for the importance of the articles for the investigation. And the set of the experiments for this training, the recurrent neural network using a semi-automated data collection with the API of Mendeley. And additionally, we manually search for more related articles. Yeah, this is the architecture in three phase. Is the of the study. In the phase one, pre-processing, document the first part of the first step is the document collection with Mendeley and manually for the training. The next step is content extraction. Content extraction is using PDF Plumber with Python for extract all content of the articles of the PDFs. And in the next step, three, is calculate the importance is the average of TF-IDF and SID is the average. With this, calculate importance with the content extraction. And in the step 4, with NMF, extract the topics, main topics. In this case, for this training, using 7 main topics, extraction. And finally, in the third phase, construction, the supervised dataset. This is the more important part of this phase because the dataset is document, topic, importance. Is with this dataset can we train the regular neural network? Yeah, is dataset for everything documents. Document 1, topic 1, importance. Document 1, topic 2, importance. This is for all documents, for all topics, for training the recurrent network. In the phase 2 and phase 3, in the phase 2 machine learning training with this data frame, recurrent network, and analysis the quality metrics. In this case, using we use RMSA for evaluate the methods of the models that training with this preprocessing. And the phase 3 is the prediction. With the phase 1, with the dataset, in the phase 3, change the model in Python and with this dataset for any topic, for any principal topic, for any theme, predict the importance, the more important documents for anything theme of study. Yeah, and experimental designs, the dataset used for training recurrent network and other models is about relevant articles, and the characteristic for training is the machine learning. Articles about recollect articles about machine learning with Mendeley and manually. And for this training, use 17 articles or PDFs recollected for training and for preprocessing. The topics calculate is seven topics used um, for this training or for in this occasion, and the equation for evaluate the models is RMSA. In this part, evaluate models, recurrent networks, and matching vectorial support. This is the parameters used for this for your creations, the models, and this is the results. In the results, see the RMSA of recurrent networks is the best of the other two models. Predicted the importance the documents for TEM, and in this part is the dataset supervised create is the result of the dataset supervised before processing language natural processing language. This take here document 1 topic 1 importance, document 1 topic 2 importance, and this is for all topics. This is the result of the dataset. It's possible that for any topic, 0% of the importance, maybe in document 15, topic 1, 0% of the importance. This is the result of the dataset. Yeah. In conclusions, the challenge, the model help use the measured importance of scientific articles using natural language processing and recurrent language networks and NMF. Using this help research for find the best articles or the best journals for your investigation. The other conclusion is time. Yeah, that the use of the deep learning tools, such as recurrent networks, serves a great help in reducing the time it may take for a research to research for relevant articles for the research. And the part more interesting in this work is the future work, because use this recurrent neural network model combined with large language model to create a web tool to help in writing the state of art, passing the more related documents. Using the recurrent neural network, calculate the more important document for this investigation, and using large language model, maybe GPT, maybe Llama, for grade based in these documents, and grade the state of art. This is a great helpful for the researchers. Thank you. Questions?
Thank you so much, sir, for your presentation. If there aren't any questions, I'll proceed to the next presentation.
Yeah, sorry, I don't have any questions. Thank you.
Thank you. So the next presenter for today's session is Brian, sir, and his paper title, he will be presenting about the topic Agricultural Internet of Things, AIoTs, Threat Modeling using Stride LM. I request Brian, sir, to start their presentation if you're with us. Brian, sir, are you with us right now? If he's not present, we'll proceed to the next presentation. Francois, sir, are you present with us?
Hi, yes, I'm present.
Can you please start your presentation?
All right, let me just share my screen.
Okay, thank you. I'll
No
stop
problem.
sharing my screen, then you can start.
All right. All right. Good morning, everyone. Thank you for this opportunity. I'm Francois Volskink, and I'll be presenting my paper titled Driver Development for GPIO Devices, specifically in a Linux embedded environment. This is just some few topics that I'll be covering in this presentation. Let's get started. First off, a quick introduction. I studied my BSc in Computer Science at the University of Johannesburg at the Academy of Computer Science and Software Engineering. I'm pursuing my master's in Computer Science this year, and I've also started a job as a junior software engineer at Intellect. You can find more about me at my LinkedIn. So this project started off as an assignment that I had to do for a class in systems programming where we had to write kernel level modules. And I decided to try and pull a few of my passions together to get motivation for this project. One of those passions being physical computing, working with open source platforms such as the Arduino or the Raspberry Pi to bridge the gap between physical devices and code. So many makers and hobbyists use these open source platforms such as Arduinos to create IoT systems from scratch themselves. And this often results in a lot of code overhead if you want to create a control system that centralizes either your sensor readings or just your general control system. So the objective of the assignment that I had to complete was to write a kernel level module that had some level of complexity and performed some basic input and output. So I decided to investigate if I could set up communication between the kernel and one of these open source physical computing devices to try and produce a faster method of communication between your control system and your IoT systems. To this effect, I developed a video game controller from scratch using the Arduino platform as a basis for my investigation. So the components of this project are twofold. Firstly, I have a Raspberry Pi computer running a version of Linux known as Raspbian. It is on this Raspberry Pi that I coded the driver that would facilitate the interaction, as well as a simple user space application that makes use of this driver to communicate with the physical device. Then the game controller itself is based on an Arduino Nano, just for the smallest form factor that I could get, along with some input devices. So the controller itself consists of 6 inputs that are mapped to a unique pin on the Arduino. These inputs include 2 axes of the joystick, along with 4 different push buttons. The Arduino has a firmware running that is constantly polling the state of each of these inputs, which then gets compiled into a struct, which is written over the UART line as serial data. On the driver side, I have a connection set up over the UART port, which is configured to the same baud rate as the Arduino to listen for that incoming data and decode it into an internal state buffer, which is then exposed to the user space as the state of the controller. However, there's a bit of a danger here. If the user space reads the internal state buffer while the message is in transit over the UART line, there's a danger that only half of the message has been transmitted, so that the user space will only read a partial state of the controller. In order to fix this problem, I had to implement double buffering, where the driver itself contains the internal state buffer, but also contains an input buffer, which is used by the read method. So once the entire message has been sent over the UART line, that internal state buffer gets copied in its entirety over to the internal state buffer. And that internal state buffer is then exposed to a character device file that lives in the /dev directory of Linux, which is available to the user space. Then a simple user space program that I wrote to interact with this physical device opens a connection to that file in the /dev directory, which then serves as the connection to the physical device. And at every iteration of the game loop, this device file is read, which then sends the state of the controller through to the user space program, which then maps onto an action that the game object needs to perform. Some challenges that I faced during this project, of course, cable management, trying to get a simple form factor for a video game controller, which might have been eased up if I had a permanent soldering solution rather than a breadboard with loose jumper wires. And then secondly, during this project, it became apparent that kernel development is quite an intense task. It doesn't have any of the type safety that you are used to coming from a user space development lifecycle, as well as memory safety in the kernel space playing a massive role, because any sort of memory leaks that you expose or writing to the incorrect address might result in a crash of your kernel or a complete crash of the entire system. Next, the interaction between the physical device and the UART was quite a bit of a challenge because there was no standard way for serial communication in the kernel space up until 2017, when the serial device bus functionality was implemented as a standard. But luckily, that was solved fairly easily after reading the documentation for that. Lastly, an interesting challenge that I faced was faulty hardware. On the Arduino Nano that I'm using, the system clock is out of sync. So after a lot of trial and error, I discovered that if I set the baud rate of the receiver, which was living inside of the driver, if I set the baud rate to twice that of the transmitting rate of the Arduino, then the data can still get decoded successfully, which just shows that there is some robustness between this communication, which might end up very useful for other IoT applications, such as physical security monitoring systems that might transmit at different baud rates. Lastly, I would like to discuss just some potential expansions on this work going forward. After implementing this project, I realized that a more efficient way of setting up communication between this Arduino and the driver would be to implement interrupt-driven messages rather than polling, where once one of the input states changes, an interrupt signal is triggered, which then notifies the driver to read the state instead of the driver just constantly reading the same state. And then next off, what I would like to do is to investigate the merits of using this kernel-based interface rather than a user space-based interface between this physical device and the driver for IoT applications that might require more real-time reactions, such as the security systems or even health monitoring systems that might benefit from a quicker response that might be provided by the kernel interface. I would have liked to perform a demonstration, but unfortunately, some technical difficulties have fallen on me on this side, and I cannot hook up the Raspberry Pi to an interface that I can use to demonstrate to you. But if you have any questions further, please let me know. Otherwise, I will leave that as the conclusion of my presentation.
Hi, Francois. Do you have a picture of your system?
The best picture I can provide is this. Otherwise, I can quickly share my camera. I do have the physical controller present with me. Would you prefer do it
No,
that way?
that's fine. I was just thinking you're using breadboard to construct your circuits.
Yes.
Okay. Did you have any issues with the breadboard? Because breadboard is not necessarily a very good way of implementing.
In this case, I did not have any issues with the breadboard.
Okay.
It provided a nice and stable base for me to present this video game controller on. If I had more time, I would have liked to have a proto board maybe that I could solder the connections on properly instead of relying on the bus lines inside of the breadboard. And then I could have a better form factor, but unfortunately, the resources available to me at the time were not sufficient to be able to do that.
I understand. Thank you so much. Cheers. Thank you.
Thank you very much.
Thank you so much, sir, for the presentation. Now we'll proceed to the next one.
Right, thank you very much.
Uh, Lenience, ma'am, are you present with us right now?
Yes, I am.
So the paper title for your the use of blockchain for identity and access management in multi-cloud. Ma'am, I request you to please start your presentation.
Thank you.
I'll stop sharing screen.
Please let me know if you can see my slideshow.
Yes, we can see.
Thank you. Good day. My name is Lenience Moyo. I'm a student at the University of Johannesburg. I'm studying for Masters in Computer Science, being supervised by Dr. Yako Dutoy. I'm excited to be here today presenting on the use of blockchain for identity and access management in multi-cloud. Before I actually go to my presentation, I'm also a consultant at a company called Business Systems Group, also known as BSG. The presentation structure will be as follows. We'll start with the background of the problem. We'll then look at identification, authentication, and authorization in the cloud. We'll look at identity management in the cloud. We look at federated identity management in the cloud. We look at identity management solutions that have been proposed by existing literature. We'll then look at the cloud block model that we've implemented and tested. We'll then conclude the presentation. So the problem we're trying to solve is that in most cases, access to multiple cloud providers causes an individual to lose control over their own identities. Now, what we've done is we've implemented and tested a solution called the cloud block. The cloud block utilizes the blockchain that enables a typical user to stay in full control of their own identity, even if it is used between multiple cloud providers. What does a user need? Why does a user need a digital identity? So a user needs a digital identity to access services from various cloud service providers. Unfortunately, cyber criminals are actively looking to steal user information. So when you read information security related news, you will find that a user's identity is stolen worldwide every 2 seconds. And this is costing every country a lot of money, and identity theft cases are always on the rise. Did you know 22 million people in America had their identity information exposed in data breaches in the 4th quarter of 2022 alone? This was reported by TransUnion. In order for a user to gain access to a cloud service provider, they need to go through identification, authentication, and authorization. So identification is a mechanism that provides information about an unverified entity that wants to be granted access to the cloud. So an identity is established through a component called an account. The process of validating a user's purported identity is called authentication. So there are various authentication methods that cloud providers use, and this include, it could be something that the user has, it could be something that the user is, it could be something that the user can produce. So once the user has been authenticated, authorization follows. Authorization is validating what actions an authenticated user can perform within a cloud system. So identification, authentication, and subsequent authorization leads to different ways in which a user's identity is managed. So managing multiple copies of a user account and multiple access permissions in a multi-cloud environment can be difficult and complex. Now, there is what is called a federated identity management, which is an arrangement that can be made between a cloud service provider and an identity provider to allow a user to use the same identity information to gain access to all the cloud providers in the group or in the federation. Now, federated identity management has its own challenges. There are many of them, but I'm just going to go through a few. So when various companies in a federation have different legal and regulatory requirements, complying with these might be difficult. Another challenge is that there is no guarantee that service providers and identity providers will not misuse the user's digital identity. So there are identity management solutions that have been proposed by existing literature. The one that we're going to look at now is the self-sovereign identity. Self-sovereign identity is an identity management model that enables a user to control their identity fully and enhances trust while preserving privacy. So we have used the blockchain to implement self-sovereign identity. So blockchain can enhance cloud security by decentralization, that's avoiding a single point of failure and relying on third parties that might misuse the user's digital identity. So the blockchain contents, once written in the blockchain, they cannot be changed or deleted without the entire architecture being invalidated. Now we'll look at the model called the cloud block that we implemented and tested. The cloud block model is made up of cloud service providers here in blue. We have the federated authentication protocol here in pink. We have the identity provider here, the colorless block. So the identity provider is made up of the blockchain front end, and the wallet. So before a user can make use of our cloud block model, they actually need to be registered to the blockchain. They register to the blockchain through the blockchain front end. So once they successfully registered on the blockchain, they have a public key that is stored in the blockchain and a private key that is kept safely in the wallet. So what happens is when a user wants to gain access to Cloud A here, Cloud A is one of our service providers, they are redirected to the blockchain front end. So they are going to log into the blockchain through the blockchain front end. The blockchain is going to authenticate the user. On successful authentication, a token is generated and sent to the federated authentication protocol. And this token can be used to gain access to Cloud A. But if the user decides to gain access to Cloud B, while this token is still valid, they can go directly to Cloud B without having to log in again. So the important thing to note there is that this token that you're talking about was created here in the blockchain. And the blockchain basically contains the user information, like we say, it's the private key. Oh, sorry, not the private key. The private key is not in the wallet. The public key is in the blockchain. So let's look at our results. So the results is that we managed to log into the blockchain using a private key that is stored in the wallet and a public key that is stored in the blockchain. This screenshot here on our right is the login button that the user clicks when they want to gain access, when they want to log in basically to the blockchain. So when the user clicks on login, the blockchain generates a message that it sends back to the blockchain front end for the user to use their private key in the wallet to sign, to prove that they possess the public key that is in the blockchain. So we also managed to create a token using the smart contracts in the blockchain, and we used that token to gain access to more than one cloud service provider. Here in orange, we have our token that we created in the blockchain, and on the right, we have an application that is acting as our cloud service provider. So then an important point to note here is that long before this token was created, was sent to our cloud service provider, the blockchain created a secret and sent it directly to our cloud service provider here. So it is the secret that is used to verify this token from the blockchain. So if this token verified successfully means the secret was used to verify this token. So we did face some challenges during the implementation of the cloud block model. Some of them include that native blockchain platforms have limited JSON Web Token creation libraries, but we managed to find some hashing algorithm libraries that made creating the token possible, although it did take a lot of time. Another challenge is that we're using the blockchain for authenticating users, and all the transactions in the blockchain are visible to all participants. So there's a risk of exposing sensitive information to unauthorized users. But the blockchain does allow us to encrypt information that is stored in it. One of the things that we looked at is that users sign their messages to prove the ownership of their public key that is in the blockchain, instead of using their actual user identities. So there's no direct link between the user's public key and their real life identity or attributes. But still, as we mentioned, that when the user registers in the blockchain, they actually enter their information there. So what we have looked at is that, we haven't implemented this part, but it's something that we recently found out during the research, that smart contracts can incorporate zero-knowledge proofs to enable parties to interact and validate transactions without exposing the underlying personal information. This could be a great way to protect user information in the blockchain. So to conclude this presentation, we used the cloud block model to store information in the blockchain. So the blockchain was our identity provider. We managed to create a token in the blockchain. The token has enabled us to gain access to any application in a federation without the user having to log in again. We managed to use smart contracts to register the user to the blockchain, to authenticate the user, to create a token. And future research could be in creating token libraries to use in smart contracts, and so that tokens can be created quicker in smart contracts. And we also can look into using artificial intelligence to allocate or update user roles and privileges in the blockchain. Thank you. I would like to open the floor for any questions you may have.
Thank you, ma'am, for your presentation. If there aren't any questions, we'll proceed to the next presenter. I guess there aren't any questions. So I'll proceed to the next presenter. Uh, Sir, if you're present with us, let us know. Min Liang, sir,
Hello?
are you present with us?
Yes.
Okay. Sir, you may start with your presentation. The paper title for his presentation is Transforming Patient Experience in Under-Reserved Areas with Innovative Voice-Based Healthcare Solutions. Sir, I'll stop sharing my screen and then you may start the presentation.
Hello? Can you see the screen?
Yes, we can see your screen.
Okay. Hello everyone. My name is Min Liang, a student from University of Saskatchewan, and I'm delighted to share with you a project that holds the potential to make an impact on healthcare accessibility. The title of our work is Transforming Patient Experience in Underserved Area with Innovative Voice-Based Healthcare Solution. Let's dive into the details. In recent years, the healthcare sector has undergone a notable digital transformation, with online appointment system emerging as a pivotal aspect of this change. These systems offer efficiency and convenience, but they often overlook the unique challenges faced by rural and indigenous communities because of the inconsistent internet access and socio-economic constraints. Traditional phone calls, a common method for healthcare appointments, are hindered by long waiting times and limited availability, especially in remote areas. Conversely, while online booking systems are efficient, they rely on stable internet connectivity, which is not universally available in rural and indigenous regions. Our research aims to bridge this gap by developing a voice-driven online appointment system that utilizes existing telephone lines, thereby enhancing accessibility for these underserved populations. To counter these challenges, our project introduced an innovative system that combines the simplicity of voice call of online booking. This hybrid approach, utilizing advanced voice recognition technologies and large language models like ChatGPT 3.5 and Whisper, converts spoken words into digital data. Our work integrates this voice-driven system with existing online booking platforms or manual booking systems. This approach offers a more intuitive and inclusive appointment scheduling process compared to standard chatbots, while circumventing issues of internet dependency. Our work holds significant potential to help the healthcare access, ensuring that technological advancements do not exclude rural and indigenous communities. By improving the efficiency of booking appointments and minimizing waiting times, this system is poised to enhance patient experiences in these communities. Moving on to the methodology, let's dive into the key phase of the voice-driven appointment system integration. We call it VDAI methodology. Each careful designed to enhance the appointment booking process in healthcare setting, particularly focusing on rural and indigenous communities. The first phase involves configuring a cloud-based telephone services as the primary interface for receiving patient calls. This cloud-based solution ensures accessibility even in areas with limited technical infrastructure, aligning with our goal of a low-cost, scalable solution. We have also made some experiments on VDAI methodology. These experiments are aimed to evaluate the system's performance. Our initial experiments focused on evaluating the accuracy and efficiency of the VDAI using whisper voice recognition technology. Through 5 rounds of testing in different noise conditions, we find the system proficiency in transcribing key information crucial for healthcare appointment. Throughout the testing, we observed varying accuracy levels, particularly in the presence of background noise, challenging arouse, especially in street noise conditions, leading to misinterpretations in address transcription and occasional inaccuracies in recording time preferences. In experiment 2, we evaluated ChatGPT 3.5's ability to simulate a hospital telephone appointment services. We create virtual patient profiles with distinct availability scenarios, accessing the system's efficiency in scheduling and managing patient information. Scenarios included patients available at any time within the hospital's slots, particle overlaps, and availability only outside the designated slots, while ChatGPT 3.5 demonstrated success in scenarios aligned with the hospital schedule. Challenges arose in more complex situations. In scenarios with particle or no alignment, the system tended to prioritize patients' most recent availability, leading to inaccuracies in scheduling. This result highlights the limitation of using a standalone large language model for complex scheduling tasks in healthcare settings. Our proposed solution involves integrating a directive coordinator and an interactive extractor to bridge the gap, considering both patient preferences and hospital constraints. In Expert 3, we tested the ChatGPT 3.5's error handling capabilities, particularly in updating and correcting patient information during the scheduling process. Results revealed mixed efficiency in ChatGPT 3.5's ability to handle updates. The experiment emphasized the need for a more robust system capable of managing dynamic changes and corrections, highlighting the importance of a sophisticated error handling mechanism. In our test, we find while ChatGPT demonstrated proficiency in processing individuals' requests, it faced limitations when managing multiple requests. In real-world scenarios, this limitation could lead to scheduling errors, potentially causing inconvenience to both patients and healthcare providers. In response to these challenges, we propose the AI solution, the two AI agent model, directive coordinator, and interactive extractor. The directive coordinator takes the lead in establishing and enforcing scheduling rules. Its role is crucial in ensuring that appointments align seamlessly with hospital availability. By doing so, we can scheduling conflict and enhance overall efficiency. This is a pivotal aspect, especially in dynamic healthcare cities where precision in scheduling is paramount. On the other front, the interactive extractor directly engages with patients, accommodating their preferences while adhering to the rules set by the directive coordinator. This collaborative approach offers a more sophisticated and balanced system. It aligns with the flexibility required in dynamic healthcare cities, ensuring patient centricity without compromising optical efficiency. In conclusion, our research highlights the potential of the voice-driven appointment integration with the AI system in improving healthcare accessibility, especially in rural and indigenous communities. ChatGPT 3.5 experiments revealed the need to enhance the existing large language models for complex scheduling. The VDAI system, with its innovation voice-to-text, teach, and do AI agent, represents a significant advance, emphasizing the necessity of sophisticated solutions that blend large language model strengths with specialized mechanisms for non-nuance scheduling. These are all the components. Thank you for listening.
Thank you, sir, for your presentation. Now we'll proceed to the next presenter if there aren't any questions by chairs.
No questions from chairs.
Oh, okay, sir. I request Brian, sir, if you're present, to give your presentation, please.
Thank you. I'm around. Sorry, I think there was a misunderstanding of the time.
Yes, sir. It's okay. You can present it right now.
All right. So I will share my screen.
Okay. I'll stop sharing mine.
Okay. Thank you. Sorry, can I close the door for me? All right. Let me share my screen. Can you confirm if you are now seeing my screen?
Yes, sir. We can see your screen.
All right. Thank you. Thank you very much for the opportunity. The agenda of the presentation, we are going to present our paper. The title of the paper is Agricultural Internet of Things, Threat Modeling Using Stride LM. So it's myself and Dr. Jaco Tutoit were the authors of the paper. Maybe let me put in slide show format. Right, can you confirm if you are still seeing it? Hello?
Yes.
Okay, thank you. Thank you. So the whole idea.
Yes, we can see your screen.
All right, thank you. The whole idea behind this, sorry, the agenda of the presentation, we'll do a brief overview, the methodology that we use. We also look into the application of IoTs in crop and livestock production, then have a brief overview of how we model the cyber threats that are associated with the use of IoTs in agriculture. Right, so the whole idea behind this is we are seeing that there is high population growth that is going around the world. According to a research, the authors that we found out that the world population is going to increase by billions. So the increase in world population is going to affect the demand for food. It means there is need for innovative ways for farmers to actually be able to produce food. And as we know that as population increases, there is also an increase in the need for land for agriculture. So all those kind of technologies, they are important to ensure that we are able to meet the requirement, the food requirements for the world population. So agricultural Internet of Things is one of the technologies that is now being adopted by farmers to actually help to mitigate the effects of climate change and also to meet the need for food. But the use of IoT technologies comes with a lot of challenges, and cybersecurity is one of the major challenges that is associated with the use of agricultural Internet of Things. So hence the need for us to model the threats to see how farmers can actually be able to take care of cyber threats. I think the main aim, the global aim of this was to build a model. So a model to create a safe cybersecurity operating environment, but we just took a portion of it where we are looking at threat modeling. We just want to model the threats. So the methodology that we used design science approach. I'm sure we are aware of that. Design science approach is used when you want to create an artifact or you want to create a new reality, you can use it to develop reliable and valid knowledge for a design solution. Then some of the applications of agriculture, of IoTs in agriculture, this always remind me about me when I was a village boy. Back in the village, we used to herd cattle in the bush. So sometimes you would lose the cattle. So you would go for distances looking for cattle. But today with the advent of the IoTs, you can now have what they are called visual boundaries, where you put a tag on your cows. When they reach a visual boundary, they produce a sound to annoy the cattle so that they cannot go over the visual boundary. But by then, it was not the case. You had to physically look for the cattle, or sometimes we would put bells. But with IoTs now, you can actually be able to monitor the cattle, where they are, their health, etc., etc. And also you can do data collection and analysis. It also helps you with better decision making. They also help farmers with effective management of their supply chain, because they can monitor the delivery of their produce to the market, right? Then also they also help you to monitor greenhouses. So in the research, we tried to create an architecture, a combined architecture, a mixed farming architecture for farmers who actually grow crops and real livestock at their farms. This was done through research methodology. So we found out that there is an application layer of an IoT architecture. From the application layer, the processing layer where data is being processed. Then you have got the network layer that deals with the transmission. Then the physical layer, we are saying this is the layer that is in the physical environment. In the farm itself, is either the tag is mounted on a cattle, as you are seeing there, a tag that is mounted on the ear of a cattle, or you have got an IoT device that is collecting data in the actual physical environment of the farm. So this is a brief architecture for the IoTs. Then the Stride threat modeling. So Stride is you want to model threats, spoofing, tampering threats. They are classified into spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, and also further research, they added the LM, the lateral movement. So we were trying to model the threats, classifying them into these categories. So the Stride LM follows 3 different stages, where you decompose the architecture into various components, which I'm going to show you in the next slide. Then you plot a data flow diagram that is showing how data flows in the architecture, we can refer to as a system. Then you identify and perform analysis of the threads that are in the DFT, the data flow diagram. So as you can see here, we decomposed the components of the architecture. Remember, we said we have got the physical layer, the network layer, the processing layer, and the application layer. So here we decompose to say at the processing layer, what are we finding in the processing layer? For example, there you are seeing IoT devices. Then you have got in them network layer, you are seeing there is Wi-Fi, the different technologies that are used to transmit the layer. Then you have got the processing layer. The processing layer is dealing with data processing. So you have got your servers, some data is being processed in the cloud, right? Then at the application layer, you're saying this is the layer which the farmer uses to interact with the system, right? So after that, we created a data flow diagram. The data flow diagram is showing how data flows in the architecture. So you can see we have got the physical layer. These ones that are showed in red, the red dotted line, they are showing trust boundaries, right? So you see data is flowing from the physical layer, network layer, then it go to the processing layer after it has been processed, then the application layer. So as you can see, data flows in both directions, from the end user to the processing layer, from the processing layer to the network layer, and from the network layer to the physical layer, and vice versa. So after doing this, after decomposing the architecture, we then started to do threat analysis, right? We analyze from the analysis that we got, we realize that we put them into different categories, like the spoofing threats. For example, we saw that there is IP address spoofing, GPS spoofing can happen. For cloud services, there can be also be a IP address spoofing. Then when there are wireless sensor networks, you can see that there will be ARP spoofing can happen also. Then it goes to the next threat category, tampering threats, where we are saying farmers may be exposed to tampering threats, where attackers can actually tamper, do logical tampering, or actual physically tampering with the devices, even stealing the device themselves. Then at the database, at the processing layer, we see that we are prone to SQL injection. We have got data tampering. Then you also look at the physical tampering or man in the middle attack. Then in terms of repudiation, we are saying people can perform repudiation in the cloud or on the wireless sensor network, where they do what they want, they do, but they can not accept this, they can refuse the responsibility to say, it's not me, because there may not be a way to actually to do under repudiation. Right, then information disclosure. These are some of the threats that we got. Information disclosure in UAVs and IoT centers, weak authentication in database systems, or weak access control. These are information disclosure threats that we also found out. Then denial of service threats. We have got physical denial of service at the physical layer. Then we also have GPS jamming or malware installation on the actual device, which can cause the device not to function properly. Then we also look at overloading of database systems. Then overloading of cloud services. Those are some of the threat categories that we found out, or denial of sleep on the wireless sensor or on the IoT device. They can be prone to that. Then we have elevation of privileges, where threat actors can actually elevate their privilege and perform further action. Then lateral movement was now after the attacker has gained access, right? They can now move laterally across the system to pivot, right, to ensure that they have got control over the system. So basically, these are some of the threats that we found, but further research would now be looking at building a model that we can use to prevent this, to mitigate the effects of these threats. So this was just a brief overview, but and the actual research, a lot of work has been done, and for those who would want to gain more, they can go through the research paper. We have reached to the end of the presentation, ladies and gentlemen, unless there are any questions.
I don't have any questions. Thank you.
All right, thank you very much.
Thank you, sir, for your presentation. Now, as there are not any questions, so we'll proceed to the closing remarks.
Great.
Yes, sir.
Yeah, I just want to say I was really impressed by the quality of the presentations. We had presentations from a diverse range of topics, including recurrent neural networks, driver for controlling GPIO, blockchain to healthcare. Thank you very much for the presenters, and I'm looking forward to your future research outputs. Over to you.
Thank you, sir. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We will be happy to see you in the next version in 2025. All the presenters would be getting their digital certificates via email within 2 working days. And further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT. I would also want to thank our session chairs, Dr. Priyanka Sharma ma'am and Professor Bal Vidhe for chairing the session. I would want to display their certificates. As a token of appreciation to the chair on behalf of Team ICICT 2024 and Global Knowledge Research Foundation and partners. Thank you all for your valuable presence. Now, before ending the meeting, I have a kind request to every participant and session chairs to kindly turn on your cameras so that I can take a quick snapshot of this session. Ma'am, can you please turn on your cameras? We'll just wait for a few seconds until everyone's turning the camera. Thank you so much, everybody. I've taken the snapshot. You can end the meeting now. Thank you. Bye.
Thank you.